So that's some of the basic information about our routers. They move data, they manage these routing tables, and they're set as our default gateway. Well, let's look a little bit more at our routing tables. Well, our routing tables, we talked about how they help our router know where to pass on data. And our routing tables include information such as the destination network IP and subnet mask. So if we're trying to send a packet to a particular network, we're trying to send a packet to a particular server, and we say, okay, router, I don't know where this server is. It's not on my network. It's not on my link. Where do I send this to? We send it to the router, and our router says, let me check my routing tables. Okay, this IP address matches an IP address over here because I know this IP address, I know the network IP and the subnet mask that this other router handles, so I'm going to pass this along over here. Or maybe it's a network that's connected directly to me. So our router needs to know the destination network network ID IP, network needs to know the network IP, and also needs to know the subnet mask to know what addresses are in that network. So that's going to be our destination network IP and subnet mask. Our routers also need to know the next router to get there. It's not just enough that our routers say, oh yeah, I know what IP address network this server's in. What next? Our routers need to know the next router that they send that packet to. If we have our network here, we're going to have our computer over here that's connected to our router. And then this router is connected to two other routers. And this top router up here is connected to the server that we're trying to get to. So we send a packet to our router, and we say, hey, I need to get to 192.168.1.7. My computer's IP address, by the way, is 192.168.3.15. So I need to send this packet here to 192.168.1.7. Well, my router is going to check its routing tables, and it's going to say, okay, well, I have a network over here that I know I can get to, that its network ID is 192.168.1. Whichever, 1.0, and then its subnet mask is 255.255.255.0. So hey, I know how to get there. 192.168.1.7 is in this range of 192.168.1.0 with a subnet mask of 255.255.255.0. That's my network. That's my computer network ID. And that subnet mask indicates to me that this network contains computers that range between 192.168.1.0 through 192.168.1.254. So I can get there. And the IP address of the router that I need to get to is this one. So it's not just enough that our router knows the destination network IP and subnet mask. It also needs to know the next router to get there. It also helps that our router knows the number of hops to get there. Now, you may be thinking, well, I thought they only used hops in fermentation. Well, we also use hops in networking too, but it's a different kind of hops. See, there are lots of puns with networking. That's why it's one of my favorites. Hops have to do with how many other stops we need to stop at, how many checkpoints we need to stop at before we get to where we're going. Are we jumping on the beltway, and am I going straight there, or am I going to hit a few red lights on the way? Am I going to hit a few other routers on the way and have to pass this message along? Those are my different hops. For those of you that may have taken military flights before, they refer to, they have different hops where you stop and you change over to a different plane and you go on to your next hop, your next leg of the trip, or a layover for some of you that may have just taken standard flights around the world anywhere. You may have a layover. So if I'm talking to one router and that router is only hitting one more router before it hits my location, then I only have one hop. I have my router plus one hop to get to where I need to go. So knowing the number of hops helps, because hypothetically, I'm not going to draw the rest of our network over here, but let's say we have multiple other routers which connect to multiple other routers, which eventually connect back to this router. It'd be better for my router to know, oh hey, I only have one hop to get to here and then I'm there, or I have 7 hops to go around the world to get there. I'm going to take this path with this one hop. Now again, we mentioned that we have different routing protocols which indicate to us the best way to get to a different router. But in this case, we're just taking hop count into consideration, and we will discuss a routing protocol which just takes hop counts into consideration. But for now, that's going to be why we know how hops are important, because it lets us know the number of router stops we get to before we get there. There's other informations that our routing table may also pick up and our routing table may keep, depending on which protocol it uses to set its routing tables. It may also take things and save information such as round trip time, how long it takes a packet to get from me to this router back to me. What's my round trip time? What's my latency? What is the bandwidth that I can push over this connection? How much data can I send at once over this connection? So this is all information that our routers take into consideration. If we want to view our computer routing table, because our local computers do have routing tables, our local computers need to know where they send data, especially on our local network, in order to get somewhere, where they need to send this packet in order to get to this server, or to get to this computer that's inside of our router domain, that's inside of our network. We can go to a command prompt and simply type in route space print, and this will show us a lot of different information about our local routing table. Not nearly as much information as if we would actually go and view our router's routing table, but still a good idea as far as what a routing table looks like. When we look at our routing table in our computer, route print, and we see an on-link connection, that's talking about a connection that we're directly connected to, say through a switch or a hub, that we can directly get to without having to go through a router. So it's data like that that lets our computer know, hey, I'm going to check my routing table for this server, and it looks like I have this on link. So I don't need to send this packet to my default gateway, I just need to send it out to the switch. And the switch, once it hits there, is going to be able to correctly route this packet. Will correctly send this packet to the MAC address it needs to go. So that's why if we actually cleared our computer routing table, it would take our computer a little while in order to regenerate all that information so that it could start sending packets smoothly again. So routing tables are very important, not just for our routers, but also for our individual computers and individual nodes. And you always want to be very careful when you're doing routing table modifications, and you always want to get the permission of God himself before you go onto a router and clear out a routing table, because you may go onto a router, clear out a routing table, and now you have 1,000 people who can't connect anywhere because that router doesn't know where to go. And if it may take it a long time, it may take it a while in order to start reestablishing connections, in order to start reestablishing routes and saying, okay, this needs to go to this router to get to here. This needs to go to this router to get to this router to go to here. This needs to, and you get the idea. Depending on the protocols that we're using with the other routers in our networks, depending on how much how many routers and other routers that particular router is connected to are all factors in how long it'll take that router to regenerate its routing table. But again, always double, triple, quadruple check. Always know what you're doing and have other people with you there when you're modifying routing tables, and especially on high traffic and main routers when you're trying to do static changes or manual changes into those routing tables. So last bit here we have here that we've hit on a couple times, our protocols help us to determine the fastest path. Our protocols help us to determine, okay, even though this has a lower hop count, this way has one more hop count but higher bandwidth, so it would be better if I go this way. Or this way has less hop, this way has higher bandwidth, but it has way too many more hop counts, so I'm just going to go this way. So we'll talk about our protocols a little bit later. We'll talk about each of our protocols individually. But over these couple sections, we identified some of the major points with our routers, what our routers do, how they move data across different networks, how routing tables work, and the difference between our static or our manual routing table entries versus our dynamic routing table entries that are created using our protocols, why we set our routers as our default gateway, and more information on our routing tables, not only on our routers but also our computers. So let's go ahead and move on to our next segment of Next Hop.